If the smallest number in a data set is 21 and the largest is 111, and we want to create a frequency table with 18 classes, what should your class width be? All right, the procedure in this problem is to basically use the following formula. The following formula for class width is that class width is equal to the range divided by the number of classes. So that's your class width. The range is the highest number in the data set minus the lowest number in the data set. Again, you'll divide that by the number of classes. So if you look at this problem, they've given us the highest number in the data set, they've given us the lowest number of the data set, and they told us how many classes we want to have. So because of that, we know the class width will have to be 111 minus 21 divided by 18. If you work that out, you're going to get 90 on top, right? 111 minus 21 is 90. Divide by 18, and 18 goes into 90 evenly 5 times. One thing you want to know for this calculation for the class width is this calculation doesn't give us the precise answer all the time. In other words, a lot of times the number you get will not work. So if it's a decimal, if you end up with like 5.3, for example, you might want to round it up to a whole number like 6. If it's a number that turns out to be a whole number from the calculation directly, like in this case where we get 5, you might think, well, that would work, but we're going to find out in many cases that's not going to work. I'll demonstrate in a moment why it doesn't work, but usually when it ends up being a whole number, you should consider the fact that you might want to add a little room. So you might want to round it up to or add a little space by making it 5.5 or 5.1. And really, this is kind of more of a thing that you just have to feel out. Essentially, if you see that it's a whole number, it usually won't work. And you can confirm that by testing it. So let's talk about how you actually test it. What you'd have to do is you'd have to actually list the 18 categories. Let's say we started with 21. That's kind of an awkward place to start. You might want to start at 20, but just to make sure that it doesn't work in either case, let's start with 21. We certainly couldn't start any time after that because 21 is in the data set. So we want to make sure 21 is included. So if our first category started at 21 and we wanted to create 18 more categories, the way you do that is you take this class width value and you add it to the lower class limit. And you do that over and over and over again until you have 18 unique categories, 18 ranges of numbers, right? So let's add 5 to 21. We'll get, of course, 26, right? That would be our second category. Let's add 5 to 26 and we'll get 31. And if we add 5 to that, we'll get 36, right? Add 5 to that, we'll get 41. At this point, we've created just 5 categories. We need to have 18, right? So let's add 5 again to this. We'll get the answer 46. All right, so I'm going to run out of space. I'm just going to start over here just to demonstrate that these categories ultimately won't do the job that we need them to do, but we're going to keep working them out. So if I add 5 to that, I'll get 51. That would be another category, right? 5 to that, I'll get 56, and then 61, and then 66, and then 71. Okay, so if we count now, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then I'll have 76. Start over here to make another row here. Add 5 to that, I get 81, then 86, then 91, then 96. Okay, so let's count and see how many I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I need 2 more, 17 and 18, right? Add 5 to that, I'll get 101, and then 106, right? Okay, so that's the start of all of my 18 categories. Normally this would be in one long column, but I just didn't have the space to do that. So let's get the other side. So this first category will go from 21 up until a number here right before we get to 26. So the number that's right before 26 is 25. In other words, that's the closest integer to this number here. And if we went further than that, if we went one higher to 26, we'd of course be overlapping these categories. So we have to stop at 25 here. And if that's 25, then we get the other side by just adding 5 to that. So the next one will be 30. You add 5 to that, you'll get 35. So we're just adding that width again over and over. Remember, that's the purpose of the width. It allows you to create these categories. So I'll have 45 and then 50. 55, 60. right? 65, 70, 75, 80, 85, 90, 95, 100, right? 105, 110. Okay, so now you see the problem, hopefully. This number, 110, is the biggest number we have in our category, right? So it's, in other words, it's saying that each of these categories, right, all 18 of them, will fit most of the numbers between 21 and 111, but it won't fit 111. 111 doesn't fit in any of these categories. So in other words, we have a number in our data set that doesn't belong to any of the categories we've made up. In other words, 111 is outside of this 18 classes that we've created, or categories we've created. And because of that, it means that using 5 as a class width just doesn't work. If we'd started at 20, it would be even worse, right? If we started at 20, we would have finished even shorter than 110. So the point is, 111 doesn't fit in our table anywhere, which means we have a data value in the data set that doesn't fit into the table we created. That means we have a problem. It means the class width is not big enough. So we have to add a little space. Usually, if we have so many categories like this, 18 categories, we can probably just add a little bit of space, like 5.1 or 5.2, and that should do the job. So what that means is that instead of adding just 5, we'll start over and add something like 5.1 and see if that works. Okay, so what I'm going to do now is I'm going to actually pause the video here. I'm going to construct the table with 5.1 and show that it actually works. Okay, so now I've recreated the table using a class width of, instead of 5, 5.1. Let's get a look at what that looks like when you do that. Basically, now you can see that we still start at 21, our lowest value, right? And I add to that my 5.1 value, and it gives me 26.1. And then 31.2, 36.3, so on and so forth, all the way down until I have exactly 18 categories. If you count this, there's exactly 18 categories. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then I did the same as I did before on the other side. I brought this all the way up until right before this one starts. So right before this one starts is 26.0, because 26.1 would be the next value. And then if I made this one 26.1, I'd be running into this other category. So I need to make sure this ends before the 26.1. So 26.0 is the closest number to this one without going over, right? And so with that 26, I do the same thing. I add the 5.1, I get 31.1, then 36.2, then 41.3, so on and so forth. What you see now is that every value fits in this table, because I had values that ranged from 21 to 111, right? From 21 to 111. And you can see this last category fits 111 in it nicely. As long as your biggest value lands into your last category safely, you know you've done the table correctly. If, for example, you made the class width too large, like say you chose 6, you'd realize that the last category, or perhaps the last 2 categories, would be empty. That's not a good thing. If that happens, you haven't done it right. You've used a class width that's too large. So by using 5.1, it works out perfectly pretty much, because 111 fits in that last category, and that means that it's done its job. Essentially, we end up having a situation where the biggest number falls into the last category as it should, and of course the smallest number falls into the first category, and all the numbers that are in between would fall somewhere in between those two. Alright, and that's it. If you've done that, then your correct answer here, or an acceptable solution, would be 5.1. Last thing I want to say about this is that there may be more than one correct answer. Maybe 5.2 would have also worked here, but since 5.1 works, it's a suitable solution to the problem.